are going to look at some content from Chapter 7 right now. What we're going to look at is, first of all, how do we know if a chemical reaction has happened? And then the biggest thing that we're going to accomplish today is to learn how to do what's called balance an equation. Basically what that means is we have to have the same number of atoms on the left as we do on the right, but we can't do things like change formulas to make that happen. So let's talk about, first of all, how do we know that a chemical reaction has happened? Well, sometimes there are visual clues. We might see a color change. A solid will form. If we have two aqueous solutions and we pour them together, two solutions where stuff is dissolved in them, sometimes a solid is produced. The result will be something that turns cloudy. Bubbles forming, that is definitely an indication that a reaction has happened. A flame, that's the big obvious one. We know definitely that a chemical reaction is happening when there's a flame. These things I'm going to definitely show you once I get back to the classroom. My plan is to make a video where we can see these things in action. Sometimes, though, there's not a visual clue. We just get the sensation of hot or cold, and that is something like what happens in hot or cold packs. So a couple things that you might want to jot down from that slide. A chemical reaction happens when atoms are rearranged. So here's an example. When methane, CH4, in natural gas, combines with oxygen O2 in the air and burns, carbon dioxide, which is CO2, and water, H2O, are produced. So when we write a chemical equation, what we show are the reactants to the left of the arrow. So those are reactants are on the left. And then the products, what's made, those are found on the right. So reactants, then the arrow, which lets us know a reaction has happened, and then these are the products. Okay. The arrow means produces, and it indicates the direction of the change. All right, so here we go. Here we've got methane gas and, right, because it said it combines with oxygen gas, O2. We know it's O2 because it's shaded yellow on your periodic table. Right, those are the diatomic molecules. Then we've got producing carbon dioxide gas and water vapor. So if you notice, I have 2 hydrogens here, but I have 4 here. I have 1 carbon and 1 carbon, 2 oxygens, but then look here, I've got 2 oxygen here and 1 here, so I have 3. So this equation right now, although correct, because these are the words that we use to come up with that equation, it's not balanced. So let's talk a little bit more about what that means to balance, and then we'll discuss how. In an ordinary chemical reaction, the mass of the reacting substances must equal the mass of the products. This is a way of saying the law of conservation of mass. Right? So you can sort of think of it like a teeter-totter, and that arrow is the middle of the teeter-totter. And so whatever stuff is on the left, the mass over here has to equal the mass over here. Chemical reactions involve changing the way atoms are grouped. So it's not about creating new ones because we can't do that. It's not about making stuff disappear because you're not a wizard, Harry. We're changing the way they're arranged. Atoms on the reactant side have to appear on the product side in equal numbers, but you cannot change a chemical formula's appearance. So if we had been in class, you would know, because we would have practiced writing names and writing formulas, that a formula's charge has to be 0. Okay? Keep in mind, you can't change subscripts. Nothing new can appear, and no elements may disappear. All right, so here are some symbols that you need to know because they're going to be written. S is for solid, L is for liquid, G is for gas, and then AQ is aqueous. That means dissolved in water. All right, so how do we balance? We put the smallest whole number in front of each formula to create a balanced equation. This number is called a coefficient. And you have to remember also in chemistry, we are super lazy and we don't write ones. So if there's nothing in front of it, well, that means that there's one of them. And when you balance, remember, you can never change a subscript. Only add a coefficient. So let's take a second and let's revisit our methane. CH4 gas plus O2 gas produces carbon dioxide gas and water vapor. Okay, so what I like to do when I'm balancing is make a list. So here's my C, here's my H, here's my O. It's a list of the elements. So on the left, I'm just going to count. I have 1 carbon, 4 hydrogens, and 2 oxygens. On the right, I have 1 carbon, 2 oxygens here, plus 1 there, so I have 3 oxygens and 2 hydrogens. Okay, the first thing that I am going to do, because I see that no matter what happens, I'm going to have an even number of oxygens on my reactant side, I'm going to put a 2 in front of my H2O. So what that means is I now have 2 water molecules. So I have a total of 4 hydrogens, and then I've got 1, 2, 3, 4 oxygens. Because remember, I've got oxygen in 2 places, and I'm adding them together. So, kind of like a tennis match, now let's look back at our reactants. Well, the carbons are good, the hydrogens are, oh, oxygen. I'm just going to put a 2 here, 2 times 2, because again, that 2 tells me I have 2 molecules of O2. So now I have 4 oxygens. And I'm balanced. So your homework is going to say, list the coefficients. Well, in front of my methane, there is an invisible 1. In front of my carbon dioxide, there's also an invisible 1. So my answer for my homework would be 1, 2, 1, 2. Because what I'm doing is listing the coefficients. Okay. All right, this one looks incredibly complicated. But what I want you to look at is check the back of your periodic table. and look at the list of polyatomic ions. If you see a polyatomic ion, PO4, that's phosphate. Look, it's on the left and it's on the right. We can list that as one thing. So I've got Na, I've got a PO4, and then next is Ba for barium. Oh look, I've got another polyatomic ion. That's NO3. That's on the back also. That's nitrate. And because on the left and on the right, they're exactly the same, I can list them as one thing because they're traveling as a group. They're traveling as though they're just a single element. So counting my elements on the left, on the reactant side, I have 3 sodium, 1 phosphate, 1 barium, and then look here, I have 2 nitrates. On the right, 3 barium, I got a 2 outside of my phosphate, 1 sodium, and then because there's NO3 is not in parentheses and there's not another little number here, I have 1 NO3. Okay, so now that I've got those listed, what I'm going to do, I'm just going to start at the top of my list. I'm going to throw 3 here in front of my NaNO3. So now I'm going to change my count. Now I have 3 sodiums and 3 nitrates. Because remember, when I put the coefficient in the front, it's like saying I have NaNO3 3 times. Okay. Well, that didn't help. I'm not going to balance. So now I'm just going to look at where my PO4 is. Now notice, I can't stick a coefficient in the middle here. I have to put it in front. Well, now that 2, oh boy, it gets distributed. Now I have 6 sodiums and 2 phosphates. Remember, I'm treating the phosphate like it's one thing. I'm not doing each one separately. Well, that didn't help. And look at, I messed up my sodiums. Well, this is why we use pencil, or in this case, a digital eraser. I'm going to go ahead right now, because I noticed that this has changed. I'm going to change this coefficient to a 6, so now I have 6 sodiums, and now instead of 3, I have 6 nitrates. Oh sweet, look, if I put a 3 here in front of my barium, that gives me 3 bariums, 3 times the 2 that's outside here. I now have 6 nitrates, and I'm looking back and forth just to kind of make sure, yeah, now I'm balanced. So my homework answer for the list of the coefficients would be 2, 3, 1, 6. Okay, let's do one more example, and this one's kind of tough too. Okay, well, I got interrupted there, so we're going to start again. Carbon, hydrogen, oxygen. Let's list these. 2 carbons, 2 hydrogens, 2 oxygens. 2 hydrogens on the product side. Oxygen I have in 2 different places, so when they add together, I have 3 of them, and 1 carbon. Okay, this is called a combustion reaction. And I know that because I have O2 oxygen by itself as a reactant. So I'm going to leave O2 until last. Okay. Whenever you see O2 as a reactant by itself, leave it till last. All right, well, I'm going to start by putting a 2 in front of my carbon dioxide. So now I have 2 carbons for 5 oxygens. All right, hold on though. On the left, O2, every time the reactant side is changed, I'm going to have an even number of oxygens. So I am also going to go ahead and put a 2 in front of my H2O, which gives me 4 hydrogens, 2 oxygens, plus the 4 that are here, so 6. Why did I do that? Because I know that I'm going to need an even number. All right, so now let's look at my list. Well, hydrogen, oh shoot, if I change, that's okay. If I change this, that's going to change my carbons to 4. 2 times 2 is 4 hydrogens, so now that part balances. So now I'm going to need to use my little eraser. And this is how this goes, you guys, like for real. When you're doing these, use a pencil. It's legit like a back and forth, kind of almost like a tennis match. All right, so now I need 4 carbon. Oh, that was not what I wanted to change, was it? It was the other one. Tuck on it. See, again, this is why we use an eraser. All right, so this one, we're going to make a 4. So now I have 4 carbons. 4 times 2, I have 8 oxygens here, plus the 2 that are here. So now I have 10 oxygens. Oh, hey, look. Carbons, 4 and 4. Hydrogens, 4 and 4. Oxygens, I'm going to make that a 5. 10 and 10. Done. So my list for my homework of the coefficients, 2, 5, 2, 4. All right, now you're going to have 5 homework problems.